Hi everyone. So this is chemistry HL paper 2 May June, and that's the time zone 2, right? So let's start the paper. Yeah. So in the first question, we can say that analytical and spectroscopic techniques enable chemists to identify and determine the structure of the compound. An unknown organic compound X comprising of only carbon, hydrogen, and oxygen, determine the empirical formula. So that's so easy question. There are certain steps to do this question. We have been provided with the percentage of the carbon, the hydrogen, and the oxygen. So carbon consists of 48.6, oxygen consists of 43.2, that's oxygen, 43.2, and for the hydrogen, their sum minus 100 minus their sum, so it should be 8.2. That's so easy, like 100 minus the sum of 48.6 plus 43.2, we will get the percentage of hydrogen. So the first step is divided by AR, atomic masses. So 48.6 divided by 12.01 and 8.2 divided by 1.01 and 43.2 divided by 16, we will get the certain values like 4.05 and 8.12, and for oxygen we will have 2.7. Now the step 2 is divide by the smallest. So which one is the smallest one? So smallest one is 2.7. So we have to divide by 2.7 all the values. So that's the way to solve. So we will have for the carbon, hydrogen, oxygen, we will have 1.5 for the carbon. For the hydrogen, we will have the 3. For the oxygen, we will have the 1. So now we have to multiply with the suitable number. So we have to multiply with 2 because 1.5 is not the whole number. So we'll get 3 ratio 6 ratio 2. So the empirical formula will be C3H6O2. So that's a 3-mark question. You will get 3 on 3. So the next question is identify the fragment responsible. Mass spectrum of X is shown. You know what? You have to check the MR. For the 74, it is the whole thing has the mass C3H6O2 plus, because the full MR is 74 of this particular compound. And for the 45, now you have to see what is the thing. That's the unknown organic compound. We have only the fragments, right? So you will see the data booklet. So you will find the carboxylic group has the peak, or yeah. So carboxylic group has a strong peak of this. And you know what? That's the clear indication of the carboxylic group present. You will see the data booklet. The carboxylic group peak is from 2500 to 3000. That's a very, very strong peak of the carboxylic group. So, and the OH group, OH present in the carboxylic, by the way. So that's why we can say that over this is just because of the OH. And you know what? That's a very strong peak of the carbonyl group. You will find the carbonyl group peak, this. So that's why we can say that like the OH and the C double bond O. These are the groups which gives these peaks. You always remember between 1500 and 2000, the sharp peak indicate the presence of C double bond O. Now reduce the structure. So MR is given, that is 74, which is C3H6O2 plus. And over 45, we have the fragment of the carboxylic group, right? So that's why. And it has 3 carbons, so it is a carboxylic group. There are 2 oxygen. Yeah, so it should be a carboxylic group. It can never be an aldehyde or ketone because it not fulfill the thing. So it should be. How do we know it is not an ester? How do we know this is not an ester and carboxylic group? Just because of 2 things. First, at 45 we have the carboxylic group peak, and second we have OH group at 3000. Ester will never have this peak. So that's why that this is the structure. So 0.363 gram of organic liquid Y was vaporized completely at 95 degrees Celsius, and 100 kilopascal the gas volume was measured to be 21, determine the MR. That's so easy. We have to apply PV is equal to nRT. We have to identify the MR. So molar mass, so PV is equal to mass over molar mass times RT. So molar mass will be equals to mass times RT divided by PV. That's the expression. We will have the mass, which is 0.363 times R is always 8.31, and temperature is given, that is 95 plus 273. We will have 368 divided by pressure is 100 times volume should be in meter cube, so 0.0810, right? So that's the way to solve. If I solve this question, so 137.047. So that's the way we need to know. So it should be 137. Now the second question is, nitrogen dioxide is a brown gas found in photochemical smoke and has a pollutant, okay, and cause acid deposition. So nitrogen oxide exists equilibrium, that is dynamic equilibrium, and at 100 degrees Celsius the Kc for this reaction is given, that is 0.0665. Since this Kc is less than 1, so if Kc is less than 1, so reaction hardly to process, or it should be a reverse reaction. So reaction, why? Because we have Kc less than. Why? Because Kc is basically product over reactant. That means if Kc is less than 1, predominantly there are reactant present. So that's why we can say that reaction is hardly to proceed. Or we can say that this is the reverse reaction. This is the reverse reaction. That's what we need to know. Calculate the Gibbs free energy change for the equilibrium at 100 degrees Celsius. Now, what is the Gibbs free energy? Gibbs free energy is delta G is equal to, there are two formulas, delta H minus T delta S, or delta G. Second formula is negative RT ln K. So we have to see the equilibrium. So equilibrium we need K, that's why we have to use delta G is equal to negative RT ln K. So negative 8.31 times temperature, since is K values given to us, that is 0.0665. 373 is the Kelvin temperature times ln K, so log natural of 0.0665. So we will have the delta G value, which is positive 8.40. Positive means this reaction is not feasible. That's what we need to know. Calculate the value of Kc. So Kc is equal to Kc inverse, because now the reaction is start from there. So it is 1 over 0.0665. So it should be, we have to take the reciprocal. So that's how we can solve this question. So let me calculate it. So it is 15. Okay. Now we have the calculate the standard enthalpy change. We have formation data. So formation of, that's so easy question. Let me solve this question for you. N2O4 convert into 2NO2. We have to find this delta H change, whatever the change is. We have been provided with N2O4 and NO2 formation. So nitrogen and oxygen is required in order to form this, and nitrogen and oxygen required in order to form this. We need to balance this. We have to put 2 there. So now we have been provided with the formation of N2O4, which is 9.16. We have been provided with NO2 formation, which is 33.18. Since there are 2 moles, we have to multiply with 2. Now we have this expression. We have to use this expression. So from where the 2 tails start, we have to write start there. From where the 2 heads end, we have to write end there. So that's the direct route. That is the indirect route. So it would be 9.16 plus delta HR, which we have to find, is equal to 33.18 times 2. So that's the expression we have to make, and then we have to calculate it. So delta HR is equal to like 57.20 kilojoules per mole. Next, calculate standard entropy. What is entropy of the delta S product minus reactant? Because we have been provided with the product entropy and reactant. So delta S product minus delta S reactant. So product is this. So 2 times 240.06 minus 304.29. That's it. That's so easy. That's so easy question. So it is 145.83. And always remember the unit is joules per mole. Draw the Lewis structure of N2O4. So you have to make nitrogen, and then oxygen. There are 4 oxygen. So these are the oxygens. So you have to make one there, double bond, one there, double bond. So, and now you have to make the lone pair. Over nitrogen, it make all 5, 1, 2, 3, 4. So over oxygen, you can make the, to complete its octet. Nitrogen is fully completed, so no need to put more electrons on nitrogen. That's the Lewis structure. NO bond length, all are this, 1.19 meter times this. What the bond length indicate the structure? Good question. So we have, you know, the bond length, they all are this. What that mean? All are same. If the bond lengths are same, that mean it may have resonance structure, because for the resonance all the bonds should be have the same length. So it has resonance structure. Predict the ONN bond angle. Oh yeah, so that's good. ONN bond angle. So look at this. It is the trigonal planar, because there is no, that is the AB3 structure. It looks like AB3 structure. So AB3 is always trigonal planar. So we can say that it is trigonal planar, and trigonal planar, they always have the angle 120 degree. Acid deposition is formed when nitrogen oxide dissolved in water. So write an equation for nitrogen 4 oxide reacting with water to produce 2 acid. Yeah, so nitrogen oxide, nitrogen 4 mean its valence is 4, that's NO2. Whenever it reacts with water, it forms 2 acids. There should be nitric acid, HNO3, and nitrous acid, HNO2. So in order to balance, there are 2 nitrogens, so you have to put 2 there. These are gas. Water is liquid. These are acids. These are aqueous. Electrolysis and Ringler titration are both application of redox reactions. An electrolytic cell was set up using inert electrodes and dilute aqueous solution of magnesium chloride. Annotate the diagram to show movement of particles that conduct electricity in the cell. So what are the cells? Magnesium chloride, it has the magnesium ion and chloride ion. Since it has water, because it's aqueous, so it has hydrogen ion and hydroxide ions. So over there, anode, so hydroxide ion has, because that's aqueous, dilute aqueous, so, and hydrogen ions, they will move towards the cathode, and chloride ions and hydroxide ions, they will move. It should be anode, it should be cathode. So over there, it lose electron and it gain electron. Reduce the half equations now. you have to see the reactivity series, and you have to see the electrode potential, which one has the greater tendency to accept. So hydroxide has greater tendency than chloride, so you have to make at positive electrode hydroxide ion at first. It forms half oxygen gas plus H2O plus 2 electron. That's the equation. Now hydrogen has higher electrode potential than magnesium. So the thing which has the higher electrode potential always has greater tendency to move towards cathode. So that's why you have to write 2H plus aqueous plus 2 electron to form hydrogen gas. Graphite rods are sometimes used as inert electrodes. Describe the structure of graphite and explain why graphite conduct electricity. So yeah, it has the layer structure. It has the layer structure of carbon, and each carbon attached with 3 carbons due to one free electron which can pass through gaps between there. So due to that free electron, it conducts electricity. The electron is delocalized. So these are some equations. So can be used to determine the biochemical oxygen demand BOD of a water sample. One set of equations for the reaction occurring is this. So we have 150 cubic centimeter of water sample was tested using Winkler titration. 36 of 0.005 sodium thiosulfate solution was required to reach the endpoint. So determine the concentration of oxygen. So that's so easy question. That's you have to apply the moles. You have been provided with the volume. We have been provided with the concentration of sodium thiosulfate. Sodium thiosulfate is over there. This is sodium thiosulfate, S2O3. It has the concentration. So we need to find the moles. Moles of thiosulfate, which is S2O3 negative 2. So the concentration is given, that is 0.005 times 36.0 divided by 1000. So 1.8 times 10 is power negative 4. Now you have the moles of S2O3, which are the half the moles of I3, and I3 moles we will get the I minus moles, and I2 moles. From I2 moles we will get the MnOH moles. From these moles we will get the oxygen moles. So what are the I2 moles then? So it should be I2 moles, they should be half. How do we know? 2, 1, and from this and this they are same. So indirectly I2 moles should be half. So 1 by 2 times 1.8 times 10 is power negative 4. So we will get the 0.0009. Now from I2 we will get the manganese moles Mn2 plus, and from Mn2 plus we will get these moles, they are same. So from I2 the manganese moles and eventually the MnOOH 2 moles are same, which is 0.0009. Now from oxygen moles, now from MnO and oxygen the ratio is 2:1. What that mean? Again we have to half. So for oxygen moles, we will already have these moles, so 2:1. Since the ratio is 2:1, 2:1. So half the moles of MnOOH2, we will get the oxygen moles times 0.00009. So it should be 0.00045. So that's how we will get the oxygen. Now we need concentration of oxygen moles, which are 0.00045 divided by the volume, which is given to us, 150. So 150 divided by 1000, we will get 0.15. 0.15. So that is 3 times 10 raised power -4 moles per decimeter cube. That's the way to solve this question. Outline how BOD of water could be determined. What is BOD? That is biological oxygen demand. Like how much biologically, what kind of dissolved oxygen is required in water, which is removed by biologically. So that's biological oxygen demand. So we have to measure the dissolved oxygen in water first. So measure dissolved oxygen in water. And now we have this oxygen value, which is basically just we calculate. So difference between two values, it represent the BOD. So difference between two values, the value that we calculate and the value we measured in water. So that is BOD. And suggest how the what a low BOD value indicates about water. Low level of oxygen is consumed. Like low level of oxygen is consumed, because biological oxygen demand or chemical oxygen demand is the how much how bacteria that because dissolved oxygen is the amount of oxygen necessary for aquatic life. That's very important. And biological oxygen demand, like to decompose anything, the amount of oxygen required by any biological organism. So that's why we can identify if we have the dissolved oxygen level. Consume. So low level, if low BOD means low level of oxygen consumed. The periodic table provides information about the electronic configuration and physical and chemical properties of elements. Bismuth has atomic number 83. Deduce two pieces of information about the electronic configuration of bismuth from its position of periodic table. So bismuth, we can say that from the two pieces of information. Of course, it belongs to fifth group. It has 5 valence electrons. 5 because group number represent the valence electrons. Since it is in group 5 or 15 and period, it occupies, what shell is this, we have to see from the periodic table, the period, 6 period. So 6 period mean it has like 6 shells. Six shells. That's what you need to know. Why aluminum is malleable? The malleability of the thing is represented by the layers can slide past. So layers of metal slide past due to repulsion between positive ions. Positive ions in metals, that's why. Okay, like the positive ions, when we exert the force, the positive ions, they repel each other. When we exert force, they repel each other and they show malleability. Okay, so 11.98 grams of black pure aluminum is heated. Calculate the heat energy absorbed in joules. So yeah, that's very easy question. So Q is equal to mc delta T. So mass is given, which is 11.98 times specific heat capacity is also given 0.902 times change in temperature is 40 minus 18. So that's how we will calculate. That is 238 joules. So argon has 3 naturally occurring isotopes. Identify the technique used to determine the relative proportion of isotopes. Yeah, that is mass spectrometry. Used to identify not only the percentage abundance of the isotopes, but also the exact AR. Yeah, that's very important. So composition is given, calculate the relative atomic mass. That's so easy. So AR is, what's the formula? You know the AR formula? We have to multiply the percentage composition with the AR, like 36 times 0.34 plus 38 times 0.06 plus 40 times 99.6 divided by 100. That's the way to solve this question. So 39.99, that is the answer. Methanoic acid is a monoprotic weak acid, calculate the pH. How do we calculate the pH? The formula is, we have been provided with the sodium hydroxide. So we have been provided with the hydroxide and concentration. So hydroxide and concentration is given, which is 0.2 moles per decimeter cube. So how do we calculate the POH? POH is equal to negative log of hydroxide ion concentration. So negative log of 0.2. So we will have 0.699. So in order to calculate pH, formula will be 14 minus POH. So 14 minus 0.699. So that is 13.301. Equation, reaction of methanoic acid. That's so easy. Methanoic acid is HCOOH. It reacts with sodium hydroxide. It forms sodium ethanoate. So HCOONA plus H2O. liquid. So we have the determine the concentration. That's so easy. Like we have the volume. We have the volume of sodium hydroxide, that is 22.5, and we have the volume of methanoic acid, that is 25. Determine the concentration. So we have to find the concentration of methanoic acid. So volume 22.5 divided by 25 times the concentration, which is 0.2. So we'll get 0.18 because the concentration is given to us, that is 0.2. Look at this. So we have to use this, right? 22.5 divided by 25 times the concentration of sodium hydroxide. We will get the concentration of methanoic acid. That's a way. Calculate the pH of the original solution of methanoic acid. Either answer this. Okay. So from the Ka value, we will find Ka is given in data booklet, so that is 10 s power negative 3.75. That's a Ka, 1.78 times 10 s power negative 4. And in order to find the hydrogen ion concentration, the formula is, you know this thing, the Ka times m. That formula is derived from this. Like Ka is equal to hydrogen ion square divided by initial concentration of acid. That's the formula. That's the formula. So we can easily find the hydrogen ions by under root Ka times acid. That's the formula. So that's why now we have the Ka value, which is 1.78 times 10 is power negative 4 times concentration is given to us, that is 0.18. We can easily find the hydrogen ions, which is 5.66 times 10 is power negative 3. Once we have the hydrogen ions, we can easily find the pH by applying the formula. pH is equal to negative log of hydrogen ion. So negative log of 5.66 times 10 is power negative 3. That's the way to solve this question. So which is 2.247. Identify the giving a reason suitable indicator for this titration. We have to see again data booklet. So from the data booklet, we can see the range. So phenolphthalein is the indicator. Because color change in the pH range. pH range of equivalence point. That's why. Write an ionic equation to show solution of sodium methanoate does not have pH 7. So you know, this is the methanoic acid. And when it reacts with water, it forms the sodium methanoate, sorry. Sodium methanoate mean it has like HCOO minus aqueous. It reacts with water. So it forms HOOH aqueous and it generates hydroxide. So that's why it is not giving the pH due to the formation of hydroxide. It's not the pH 7. So that's the reason. That's the reason. So just an experimental method that could be used to determine the rate of reaction. So yeah. So you have to measure the mass, change in mass with respect to time, and volume is also produced. So you can measure the change in mass, you can measure the change in pressure, you can measure the change in volume of gas, and also electrical conductivity also used. So these are the methods. The sulfuric acid is catalyst. The reaction explain how catalysts increase the rate of reaction. Provide an alternative pathway with lower activation energy. Provide an alternative pathway with lower activation energy. Ethanoic acid can react with ethanol to produce an ester. Yeah, that's so easy, so easy. Draw the full of organic product. So react with ethanol. So methanoic acid is this, and it reacts with ethanol. So ethanol has 2 carbons. So that's the structure. That's so easy, and it should be methanoic acid. So that's why it should be methanoate, huh? Because the second name of ester is come from the carboxylic acid and ethanol, so it should be ethyl. So ethyl methanoate. Predict the number of signals separating pattern proton NMR of this product. Yeah. So how many like we have like how many different proton in this compound? We have 1, 2, 3. So we have 3 compounds. So how many signals we should have? 3, because we have 3 different environments. Always remember, this is the one signal, this is the second, because these 3 hydrogens are in same environment. These 2 hydrogen are in same environment, and this one. So there are 3 signals. And this will give the quartet because it has 3 hydrogen. This will give the quartet. This will give the triplet. This will give the singlet. So singlet, triplet, and quartet. You know this splitting pattern? The neighboring hydrogen, they represent. For example, if you look at these hydrogen, in their neighbor, there are 2 hydrogen. So this will give you triplet. Why? Because the formula is n plus 1. How many neighbor hydrogen? 2 plus 1, it will give triplet. So the pink one, the red one hydrogens, their neighbor, the green one, they are 3. So these red hydrogens, it will give the quartet because according to n plus 1. So that's why. State one reason why tetramethylsilane, TMS, that's the solvent. Often choose an internal reference. That's why, because it is having the singlet and it do not have no separating pattern. That's why. That's the reason. And it is not going to react. It is very inert and it is soluble. So these are 3 reasons: inert, soluble, and no separating pattern. Write an equation for complete combustion of ethanol. That's so easy. Ethanol is C2H5OH When it burn in oxygen, it always form carbon dioxide because that's a complete combustion plus water. In order to balance the carbon first, balance the hydrogen then. So 2 to the 4 plus 3, 7. So we have one oxygen already there, so you have to put 3 there. Determine the enthalpy change of combustion using, yeah. So bond break minus make. You have to, that's a 3-mark question. You know ethanol, how many bonds are there? You have to see OH, then oxygen, 3, then carbon dioxide, 2, plus then water molecule, 3. You have to see the bond, you know the formula? Bond break, which is reactant, minus bond form. That's the formula. You have to see all the energies. So bond break energy is 4731 minus 5994. So these energies you will get from periodic table. You already learned in MYP this question as well. So that's so easy. So from data booklet, sorry. So 1263 kilojoules per mole is the answer. HBr reacts with but1-in. Yeah, that's so easy. Look at this. But1-in is alkene. Alkene always gives the electrophilic addition reaction. So, electrophilic addition reaction. The mechanism CH3, CH3. So I'm going to make the mechanism. So HBr. So hydrogen has partially positive charge. Bromine has partially negative. So pi bond is going to attack to hydrogen. This bond is going to break. So major. So for the major product, by the way, it will give the, is that but1-in? I'm sorry. That is but1-in. So hydrogen there, double bond, carbon. Again, now the hydrogen goes to the carbon. The positive charge goes to the carbon, which has less number of hydrogen. So that's why positive charge should be there and CH3. Now the Br is going to attack because it's more stable. It's the secondary carbocation which is more stable. That's why. Now the product should be CH3, CH2, CH bromine there and CH3. Explain why the mechanism result in one product being formed in greater quantity. Why? Because due to, we can say that more stable intermediate, that's a 2-mark question. We have to write like secondary carbocation is more stable, it has greater positive inductive effect. Is more stable since has more positive inductive effect. Draw the structure section of the polymer of but1-in. We have to draw the structure. So since that is but1-in, that means double bond. If we remove the double bond there, so hydrogen. Now that this carbon has CH2, CH3, 1, 2, 3, 4. Yeah, and hydrogen there. Then we have to make this because we have to make 3 monomers. Again, CH2, CH3. Then again we have to make the same one. CH2, CH3. So this is the 3 repeating units. Deduce the hybridization in first 2 carbons of butanene. What is the butanene? This is butanene, first 2 carbons. So they all are double bonds, so it should be sp2. Single bond are having sp3, triple bond having sp. Describe the bonding between first 2 carbons in terms of orbitals. So always remember in sp2 it is having, if we check the double bond, look at this. So that is, since it is sp2, so now the sp2 overlapping, it will give the sigma bond because that is head to head overlap. And pi bond is formed pz orbital and pz orbital sideways overlap to form pi bond. So sigma bond, how many sigma bond? 1, 2, 3. 3 sigma bond there. And 4, 5. And 1 pi bond. Pi bond is only formed just because of PZ overlapping. So one isomer of C4 exists as, draw the 3-dimensional structure of the, yeah. So it should be this, like this. It has bromine, C2H5 and CH3. That is having the optical isomer, and they have 2. So because they are mirror image to each other, like this. So that's the Hess cycle. So magnesium solid turns into magnesium aqueous, and so that's solution. When solid turns into aqueous, that's enthalpy of solution. Always remember, when gaseous ions turns into aqueous, the C1, gas to aqueous, that's enthalpy of hydration. We are talking about C. And when gas to solid, that's lattice. So lattice enthalpy. Or solid to gas, that is lattice enthalpy. And you can make the Hess cycle. That's start, that's end. So this is the direct route, this is the indirect route. So A is equal to B plus C. So like enthalpy of solution is equal to lattice enthalpy plus hydration. So lattice you can see from the data booklet 2340 plus hydration is negative 1963 for the magnesium, and for the chloride it is negative 359. You can see, you can solve it to get the answer. So that's the solution enthalpy. That's so easy. Why the lattice enthalpy of the like barium chloride is lower than that of magnesium chloride? So why? Because barium size is greater. So ionic radius of barium is greater. And you know what? When the size, the radius is going to increase, the attraction, the lattice enthalpy is going to decrease. Greater than magnesium ion. So greater attraction or weaker attraction. Weaker attraction. Weaker attraction between barium ion and chloride ion. Cobalt also formed chlorides. State the full electronic configuration of cobalt. That's so easy. It has 27 electrons, so 1s2, 2s2, 2p6, 3s2, 3p6. It is 2 plus, so 4s0. So it becomes 3d7. Hydrated cobalt pink, describe the interaction between cobalt ion and water molecule in terms of bond. So it's coordinate covalent bond. Always remember, whenever you see the hydrated compound ligand, they form coordinate bond. How bond formed? Water act as a ligand there. Ligand, it donate lone pair. So it's blue in color, explain why the different ligands has different colors. So the, you know what, they absorb the light. So magnitude of energy. So they absorb different frequency of light. And d orbital split into different energy. Yeah. So that's why they show different colors. Okay, reduce the overall rate. That's so easy question. You have to see the change when the other things are constant. For example, look at this. The bromine concentration is constant, bromide is constant. Change in hydrogen and change in initial rate. You have to see the change in hydrogen and change in initial rate. How do you know? Like hydrogen ion change with respect to hydrogen ion, 0.6 divided by 0.3, divide them, and 8.60 times 10 raised to power negative 6 divided by 2.13 times 10 raised to power negative 6, and see the sequence. So you will get the 2 and almost 4. That means with respect to hydrogen ion, it is second order. Similarly, you have to see the same sequence when hydrogen and constant, bromide is constant, bromate, check bromate. So you will see that's first order. So with respect to bromate, it is first order. The way is same. The way is same. And with respect to bromide, it again first order. First order. So what's your rate equation then? Rate is equal to K into hydrogen. You have to put square there. Bromide and bromate as it is. That's your rate equation. Okay, the last question. The rate of reaction at 50 degrees Celsius is 3 times at 25. Calculate the activation energy. Now you know the formula, that is ln K1 over K2 is equal to activation energy over R 1 over T2 minus 1 over T1. Ln rate is 3 times, so 1 over 3 is equal to activation energy. We have to find R is 8.31 times. Temperature is 323 minus 298. So you have to rearrange them and calculate the activation energy. So you will find that is 35.1 kilojoules per mole. That's it. Thank you so much. That's the paper.
Thank you for staying with me to the end. Don't hesitate to leave your question or request in the comment section. I'll see you guys next time.